Hi everyone. The objective of this project is to accurately forecast power output using machine learning for a combined cycle power plant. I will cover the data exploration, correlationship between the features to the target variable, the metrics evaluation, and finally the recommendations on the model. This is a supervised regression model because the target data as well as the input features, they are of numeric type, continuous and labeled. I have considered two algorithms, that is linear regression and random forest. Linear regression because I assume that the features and the target have got linear relationships, and random forest because there is no assumption considered to be on the data distribution, and we rely on ensemble of decision trees where it learns the patterns directly from the data that it uses. There are four different types of features. That's ambient temperature AT, exhaust vacuum V, ambient pressure AP, and relative humidity. The datasets consists of 9,560 rows. We have the target variable defined as PE, which is net hourly electrical energy output, and it's in megawatt units. As I mentioned before, we are considering linear regression and random forest. In order to evaluate the performance of the model, I have taken a cross-validation split approach. The k-fold cross-validation splits the training data into 5 folds. It trains on k-1 folds, validates the model on 20%, and repeats this process 5 times. Let's go to the evaluation metrics. Root mean squared error is the first one, followed by the mean squared error. RM's SE because it's easier to interpret and penalizes the large errors. Mean squared error because it reduces the big errors, gives us a smooth and differentiable, which is good for optimizing the algorithms like linear regression. After analysis on the correlationship between the features and the target variable, the findings showed that there is a strong negative correlation with the target variable, that is the net energy output, with the ambient temperature and the vacuum. Ambient pressure and relative humidity shows a positive correlation with the target variable. Therefore, ambient temperature and exhaust vacuum is considered as the dominant drivers, followed by ambient pressure and relative humidity. I recommend random forest as the model for better generalization and robustness to collinearity, because when the final model was evaluated on the test data, it gives us a prediction of which stood within 2 to 3 units of the actual value, which is less than 1% of the error. This level of accuracy is sufficient for operational decision making and efficiency optimization. Thank you.